Welcome to the lecture on causes of residual stress development in welding. So, we talked about the different types of residual stresses and how they are going to affect the service life of the component. So, and then how can we get rid of them also shortly. In short, we discussed about a few steps by which we can minimize those residual stresses, but then we will talk about the causes or mechanism of these residual stress development which is there in the case of welding. So, what happens that when we have so first of all, in arc welding the work will be raised to its melting point within a limited area. So, in a very limited area you are increasing the temperature to a large value, and then temperature will drop sharply as we move from the heated spot. So, the reason for the sharp decrease of the temperature is because of the high thermal conductivity of the workpiece. Then you have rapid heat dissipation. So, because on all the sides you have the metal and which has normally very high conductivity values. So, the heat dissipation rate will be quite high, and also the volume of the metal is quite high, small. So, if you talk about the casting where you have large volume of metal, and in this case you have a very small metal pool which is getting cooled. So, your that volume is also smaller, then you have rapid heat dissipation, and also the heat conductivity on the sides is higher. So, all these things basically they prevent this uniform expansion of the metal, and that basically will be the responsible factor for the development of the internal stresses. So, that we have already talked about. Now, so in that case we can understand by referring to one example. Say if you have if you have a steel plate. So, if you take example of a steel plate, say you have this way a steel plate, and it has 3 zones. So, basically we talk about these 3 zones in this steel plate. Now, what happens that if suppose we take this as 1, 2 and 3. So, if suppose it is subjected to heating. So, we will talk about the internal stresses which are developed in this plate, and what happens that as the zone 1. So, this is your zone 1, zone 2 and zone 3. So, this as the zone 1 will be heated in the temperature, then it will try to expand. So, it will try to go like this, and it will try to expand. So, this zone once it is heated, it will try to expand. Now, so it will be expanding longitudinally, and the length which is suppose here AB. So, that length will become A1 B1. So, this way your length of this zone will increase to from AB to A1 B1. Now, the zone 2 and this zone 3. So, they will be providing a restraint to the expansion of this zone. So, this zone will try to expand, whereas the zone 2 and zone 3, this zone 2 and zone 3, they will be restraining to the longitudinal expansion of this of zone 1. So, what happens that now that will develop the stresses on these zones. So, one is expanding, and two is basically trying to stop it because they are in contact. So, because they are not so hot. So, 2 and 3, since they are not hot, so they will be providing that restraint on that zone. Now, it will be so accordingly, so that since it will be restraining it, so zone 1 will be under the it will be under the compressive stress. So, zone 1 will be it will be developing a stress which is compressive, that is why we denote it as the negative sign. Then zone 2 and zone 3, because it has expanded, so it will try to expand the zone 2 and 3. So, zone 2 and 3 basically will be subjected to the tensile type of stresses. So, this is the type of stress which is developed in the case of heating. So, this stress development is during the heating process. So, this is during the heating process. Now, if while we are supplying the heat and when the temperature is increased at that time, this will be the type of stress which will be developed inside the material. So, then if you go further and if you talk about the cooling. So, when it starts cooling, at that time again this will be cooled. So, it will try to contract, whereas the zone 2 and 3. So, zone 1 will try to contract and zone 2 and 3 will try to restrain that from contracting because the temperature is decreasing. So, in that case what will happen? Now, zone 1 will be experiencing a tensile type of stress. So, it will be stressed basically, it will try to contract, but then it is not able to, say, a type of tensile stress is developed in the case of zone 1. So, zone 1 if you see, zone 1 will be under the positive stress, it will be under the tensile stress, and zone 2 and 3. So, you will have zone 2 and zone 3 on these sides. So, zone 2 and zone 3 will be under the negative stress, that is your compressive stress. So, that basically so what you see, that the sign of the stress which is generated inside, which is basically either pulling or pushing. So, that is basically changing in both these cases. So, so that way that by this you can understand that how your different type of stresses, that is tension or compression, which tension is signified by the positive sign and the compression is by the negative sign. So, that will be this way your stresses will be changing in the case of the joint. So, if you have the different zones, so this way your the stresses will be varying. Now, if you try to see the the stresses and strains in the butt welded plates. So, suppose you have a butt welded plate. If you talk about a butt welded plate, and in this you have the welding going along this line. So, this is your weld bead. So, so if you take this section as the XX, and if you take this section as the YY, so what happens that you have the development of the longitudinal stresses as well as the transverse stresses in those cases. So, the development of the longitudinal stresses which is developed is normally what happens that this way you have the this positive which is there on the in the middle, and on the sides you have the negative stresses. What you see finally that you have the positive stress which you see in the portion here, and you have the negative stresses on this side. So, that way you have the longitudinal longitudinal stress pattern along x-axis. And you can have also you can draw the transverse stress also along the y, and along y if you try to draw the along y you will have the you will be getting this way, that will be your type of pattern which you see in the case of the transverse direction. So, this is your transverse stress pattern. Y. So, this will be your positive and this is your negative. So, that way your stresses are basically changing. So, we can further understand it by looking at this, that if suppose you have the plate. So, and if you are doing the welding. So, suppose if you are taking about this point, this is your melted region, and you will have different zones. So, so this is your this point. So, if suppose this is x, and we are talking about the different points. So, so suppose if you talk about this zone, that is your AA. So, in the melted zone, so just it has been melted and your torch is here. So, in the melted zone, if you talk about the change in temperature and the longitudinal stress value. So, just ahead of this if you see in this case you have the delta T. So, if you talk about this point, you have delta T as 0. So, your stress is also will be 0. Now, if you look at this section which is basically BB. Now, in this case what is happening that if you talk about the temperature. So, what you see that on this side you have the temperature which is the lesser one. So, the temperature value is increasing to a very large value here, and then it is the decreasing towards this side. So, that way your this is your thermal line, that is your temperature change which is occurring, and this is resulting to your the tension and compression stresses which is being provided. So, that will be given like so this way your so this is your compression and this is your tension. So, that way your this is your in this case you have tension, and in the bottom you have compression. So, that way you have in the middle part you will have the compression, and in the top on the sides you have it is under the tension. If you go to this section. So, if you are coming to the some point here, that is your CC. Now, in this case your temperature profile will be like this, and that will lead to the stress values. So, you will have the the stress value like this, and on this side, on the middle, you will have the positive, and on the sides you will have negative. And finally, if you talk about this point, so in that case, which you see after cooling, so here again what you see is you have the delta T as 0, and the pattern which you see, so you will have this way your pattern comes. That is what we have seen earlier. So this is what you see while after cooling, you see this temperature stress distribution like this. So this is how the development of the stress goes in that case. So basically now what we wanted to know, that when we talk about the mechanical stresses, now in those cases you have basically the expansion as well as contraction going on. So in those cases this way your stress pattern will be changing, and that will be development of the residual stresses. If you talk about the other residual stress, that is your metallurgical residual stresses. So in the metallurgical residual stresses, as we talked about, that is because of the phase transformation which is taking place. So we know that you have the austenite which is changing to martensite when we are cooling. So so if you have so if you suppose have the austenite and austenite together, now when the austenite will be changing to martensite, so that way this will be your austenite, and then this will be the martensite. So volumetric change will be there. Now because of that so this will try to drag it towards the back, and this will try to pull it. So because of that so this austenite in the equilibrium case, what we find the structure. So so this is your austenite and this is austenite, and after transformation this austenite becomes martensite. And then in the final case, if you have austenite and martensite like this, so this austenite will be in tension and this will be in compression. So what happens that this is because when the austenite is converted to martensite, then that occupies more volume, so that will be expanding, and then the austenite which is near to it, so that will be trying to give the restraint to it. So that way there will be stresses which are developed, high compressive stresses are and the surrounding constituents having lesser volume. So you will have these development of these stresses which are there, and that is why the stresses which are generated in these cases, they are under the category of the metallurgical stresses. Now the other type of stress which we also discussed was the reaction stress. Now if you talk about the reaction stresses, so in the case of reaction stresses, as we discussed, it is because of the constraint which is provided, or the restraint to the thermal expansion and contraction which is offered when we do the welding. So it is not by the workpiece, but it is because of the other part of the structure to which the part is or the piece is to be of the welding is attached. So this is because of that that restraint during the welding process. So so if that happens, suppose you have two pieces to be welded. So and they are already so when you have two pieces to be welded and they are already attached with certain structure, in that case these happens. So suppose you have two pieces which are to be welded, and so these are these are the two pieces, and and they are basically on the sides, they are fixed to certain structure. So, so in such cases, when there will be heating, so they will try to so these are the two pieces. So, you have these two pieces and this is your weld metal zone. So, in that case, when there will be heating going on, so it will try to expand and so that way the stresses will be generated. So, what happens that in these cases the magnitude of the reaction stress which is generated, they are the inverse function of the length of the material. So, the length of the material is larger, then the stress which is generated will be smaller. So, magnitude of reaction stress, so that will be inversely proportional to the length of the specimen. So, the length of the material. Okay. So, it will never exceed the yield strength of the material, and if it is very very tight then it may so it will be exceeding, so its value will be exceeding many a times, but normally it does not go beyond that yield point. So, it will be normally occurring in the plate structures, or it may be in the girders or in the ships also. So, that way in those cases where we do the welding, because you have to do the welding and on both the sides you have the constraint. So, when you do the welding, in that case the stresses will be developed, and these so this is your structure, and this is your piece to be welded. So, that is the way these stresses are developed, and these are known as the reaction stresses. So, normally you have the stresses which occur in the case of different types of joints, and that varies from joint to joint. So, we have talked about the pattern of the residual stresses which occur in the normal butt welds, but in terms of suppose box welds. So, if suppose you have a box weld which is there. So, in those cases the pattern will be, suppose you have the welding here, then you have the welding here, you have the welding here, and we have the welding here. So, in those cases you will have the different kind of residual stress distribution, and normally what happens that you have if you look at this value of the residual stresses. So, you will have so it goes like this, and you will have the value here in this case. Similarly, it will go to on this side. So, you will have the value of going like this. So, you will have positive as well as negative. So, this side it is positive and this side it is negative. So, this side is positive. So, that way you will have the development of the stresses in the case of box shape. So that way you can have the prediction of the stresses in the case of box shape. So, similarly in the case of H shape also you have some stress distribution. So, that is the type of stress distribution. So, what we have studied, because the residual stresses are not so desirable, so they may result into the weld cracking or the stress corrosion cracking. They result into the brittle fracture of the material, and they result into the lower value of ductility. They will be affecting the surface fatigue properties of the material. So, that way we have and that affects the performance of the material. So, we have to see that you must have the means, or you must have the ways to decrease or to minimize the value of the welding stresses or residual stresses to the minimum. Thank you very much.